Hello and welcome to today's podcast, where we dive into the intriguing world of machine learning and explore how transfer learning can be a game changer for your projects. Picture this. It's a regular day. You're 3 cups of coffee in, feeling pretty good about the progress on your machine learning project. Suddenly, the phone rings. It's Jane, your project partner, and her voice carries that familiar blend of urgency and frustration. We've all been there, right? Our project was a model designed to classify medical images, and we were in trouble. Weeks away from our deadline, and the latest iteration of our model was performing worse than a coin flip. I could feel my confidence seep away like air from a tire, and I couldn't help but wonder where exactly we were going wrong. One of our biggest challenges right from the start was the limited amount of labeled data. Medical images are tough to come by, especially for rare conditions, and getting them annotated is both difficult and expensive. We didn't have the resources to manually label thousands more. We tried data augmentation, but the improvements were marginal at best. Have you ever been in a bind like that? You know, where data scarcity feels like a wall you just can't climb. In fact, a 2024 survey from New Vantage highlights that nearly 92.7% of executives identify data as the most significant barrier to successful AI implementation. As I sat there, phone pressed to my ear, I remembered a conversation from a conference a few months back. A colleague had talked about transfer learning as a potential lifesaver for projects like ours. At the time, I hadn't really paid much attention, but now it seemed like a glimmer of hope. Could transfer learning be the silver bullet we needed? So, after getting off the call with Jane, I dove headfirst into research. I was excited, but also a bit apprehensive. Transfer learning, if you're not familiar, is about taking a pre-trained model and fine-tuning it for a new, related task. It seemed almost too good to be true. But what did we have to lose? Transfer learning is known for reducing computational costs and data requirements, which is exactly what we needed in the data-scarce field of medical imaging. We decided to use a pre-trained model on ImageNet and fine-tune it for our specific dataset. The initial setup was surprisingly straightforward, but as they say, the devil is in the details. We had to optimize the model's parameters for our specific task, and trust me, that wasn't a walk in the park. If you're considering this path, optimizing hyperparameters is crucial. It can make or break your fine-tuning efforts. Now, it wasn't smooth sailing right away. The first few iterations were promising, sure, but certainly not game-changing. We spent a lot of time tweaking the learning rate, adjusting which layers to freeze and unfreeze. It felt like we were feeling our way in the dark. There were moments, I won't lie, when I thought we might have been better off starting from scratch. It's a common pitfall in machine learning projects. In fact, some reports even indicate that as high as 85% of projects fail to reach production due to data quality and deployment issues. But then, slowly, things started to shift. Our validation accuracy began to climb, incrementally at first, then in genuine leaps. What's fascinating is how quickly the model started to understand our specific image features once it had that foundational knowledge from transfer learning. I remember one night, it was around 2 a.m., and I saw the results of the latest training run. I actually laughed out loud, a kind of relieved, disbelieving chuckle. We were finally seeing the performance that made the project viable. I texted Jane right away. I think we cracked it. Looking back, there are some insights that I realized and consider essential for anyone working in machine learning. First, leverage existing knowledge. Transfer learning allowed us to stand on the shoulders of giants. We didn't need to reinvent the wheel, which saved us immense time and resources. This is especially crucial in fields like medical imaging. Second, be patient with the process. It took a lot of trial and error, and we had to be flexible in our approach, not getting discouraged by initial setbacks. The path to a robust model is rarely linear. Third, don't be afraid to ask for help. I reached out to a few experts who had gone down this path before, and their insights were invaluable. Sometimes a fresh perspective can save you days of frustration. If I could do it again, I'd start with transfer learning from the get-go rather than as a last resort. It's a powerful approach, especially when you're dealing with limited data. Also, I'd place even more emphasis on avoiding mistakes in data preparation early on. Cleaning our data properly was crucial to our success. As the old saying goes, garbage in, garbage out, and that's especially true in machine learning. In the end, our project was a resounding success. We met our deadline, and the model's performance exceeded our initial expectations for classifying those challenging medical images. That feeling of triumph was mixed with exhaustion, but it was absolutely worth it. We learned so much, not just about transfer learning, but about resilience, collaboration, and the sometimes chaotic yet ultimately rewarding nature of innovation in AI. So, if you find yourself stuck in a similar situation, facing limited data, or struggling with model performance, consider leveraging transfer learning. It might just be the lifeline you need to turn the tide. And remember, the path might be messy, but that's where the real growth happens. If you're curious about other ways to enhance your machine learning process, you might want to explore the importance of data visualization for gaining deeper insights. Or consider when synthetic data could be beneficial, especially when real-world data is scarce or sensitive. Thanks for joining me today, and I hope you found this discussion as fascinating as I did. Until next time, keep pushing the boundaries of what's possible with machine learning.